This is quiz 1 from the first unit. So the first question on quiz 1 was asking us to draw a representation and name an example of each of the following. So a point, okay, so if we're going to draw it, right, we're just drawing a point, okay, and to name it, we want to name it point A, so basically we're just going to do A. So here's drawing, here's our name, point A. Okay, we could put a point after it if we wanted, but it's fine just calling it A. Okay, a line, so let's draw a line. Okay. This is our drawing, so we need 2 points to define a line. So we need to put 2 points on there. I put A and B. I should write it bigger so we can see. A and B. Okay, and we name this line AB. So we put AB up there with the line over it on both sides. Okay, to represent line AB. Put the arrows on both sides because we're going to infinity in both directions. Plane, so we have to draw a plane. So we just draw kind of a parallelogram type thing to represent our plane. With a label on it to name the plane. So then this is going to be plane pi. We could also put points in here. Again, 3 non-collinear points in the same plane. We could have named it plane ABC, or plane BCA, or plane CBA. Any of those would be fine. D is a line segment. So line segments have 2 endpoints. Okay. And then we're going to call it AB, segment AB, with a bar over it. Okay, that's how we name a line segment. Ray, so it's going to have 1 endpoint. Okay, it's going to go to infinity. And we're going to name that AB, ray AB, with the arrow over it, going in 1 direction. So line going forever in 2 directions. So we put, when we name it, we put the arrows on both sides of the bar on top. The segment ends at both of the endpoints. Right, so we don't put any arrows. We just put the bar over the AB. Okay, and then ray, we have 1 endpoint, right, A, and then it goes forever in the other direction through B all the way to infinity. So we name it with only 1 arrow the way it's going. Right, if we drew it the other way, so BA, okay, we would have had to have named it BA. Okay, the arrow on the side where it's going to infinity. Right, the endpoint of this is B. The endpoint of this is A. So the endpoint should be on the side without the arrow. The arrow is on the side that's going through to infinity. 2 lines that intersect. So here we're just drawing 2 lines. Okay, so I don't know, AB and CD. They intersect at point E. So CD and AB are 2 lines that intersect. They intersect at point E. Quiz 1, Yeshua, I'll go back and do this one much better now that you've gone through the other couple of units. But if I'm not explaining in enough detail, again, feel free to come see me. I mean, it's 6:20 at night, so I don't want to be here forever explaining every little detail if it's something you already understand. So if I'm overlooking something or skipping over something, please let me know, and I will help you to the best of my ability. Okay. Number 2 wants us to name 3 collinear points. Being collinear means points on the same line. Okay, so we want to name 3 points on the same line. Well, A, V, and H are all on the same line, right? And again, if we go back up to number 1, okay, how we named our points, right? When we named a point, we didn't name it A with a bar over it or anything like that. So when we named 3 points, right? If it said name 3 points, A, B, C, Okay, it's not ABC with a line. It's not ABC with a bar. Okay, it just wants points. So we just want points. How do we name this point? We name it A. How do we name this point? We name it B. How do we name this point? We name it C. So if we're listing it, A, comma B, comma C. Okay. Just want to be very clear on that. When it asks for a point, our answer should be points. When it asks for a line, our answer should be a line. We should know how to name these correctly. I remember that was a big issue when you guys took this originally. Okay. Number three non-collinear points. So 3 points that aren't all on the same line. Many, many different answers here. Okay. AVE, AVX, AEX, AHX, AHE. Okay, and then any ordering those however you want. As long as they're not all on the same line, then they're going to be non-collinear. Okay, non-collinear means not all on the same line. So again, point, we'll just say A, H, and E. Okay. So again, these are naming 3 points. This is point A, point H, point E. If you want to put and E or something like be more grammatically correct or something, that's fine. But put the Oxford comma because you should always write the Oxford comma. Even if your English professor in college says don't write the Oxford comma, tell them your geometry high school teacher who's not very good at English said put the Oxford comma because it makes more sense with an Oxford comma. Okay, let me scooch up for coplanar. Well, you can't really scooch it up. Okay, coplanar means, I'm going to put this here. Right, Oxford comma. Good things. Good things when you put Oxford commas. Okay, name for coplanar points. So it's asking coplanar points on the same plane. So here's our plane S. So what's the 4 points they have labeled on our plane? Well, they have A, V, H, comma, and E. Okay. A, V, H, and E are the 4 points that are coplanar. They're all on plane S. Okay. Name a point that is not on plane S. Well, if all these points are on plane S, the only other point we have is point X. Okay, the thing you want to be careful here is these two, S and L. Again, S is the name of the plane because it's in the corner of the plane. There's no dot, right? When we had to draw the representations on number 1, when we drew a point, we put a dot next to it. There is no dot here by S, so S is not a point, right? It's the name of the plane. Okay, then there's an L here. Again, there is no dot next to L, so L is not a point. Because if we drew it on the diagram, we would have a point next to it, and there's not a point, so it's not a point. It's the name of the line. Okay, so when you name your focal plane of points, make sure you did not include point L, because point L is not a point. It's the name of the line. Okay, so the point not on the plane is going to be X, the one down here. It's below the plane, right? This line, XV, is coming up through the plane. Right, here's our flat surface. Right, flat surface, and XV is coming up through the plane. X is way down here. Right, here's our flat surface. Look at X is way down here, coming up through the plane. Okay. Number 6, the intersection of plane S and line XV. So the intersection of plane S, it's right here, and XV. So here's line XV. Again, we just said it's coming up through the plane, line XV. This is plane S. Okay, it's coming up through the plane and it's intersecting right here. Right, again, it's coming up through the plane, intersecting at point V, and going up out of the page. Right, coming up, intersecting at point V. Right, you have to imagine this being out more and flat, right? And then it come up, intersect point V, and go out. So the answer here is going to be V, point V. We intersected at point V. Okay. 7, name another name for plane S. So 7 is asking for another name for plane S. So the other way to name, right, we can name it plane S. Okay. Or we can name it using 3 non-collinear points that are in the plane. So we want to pick 3 points that are in the plane that are not all on the same line. So we're given 4 points, A, V, H, and E. We cannot use A, V, and E because they are on the same line. We need to use 3 non-collinear points. So let's just use A, V, and E. Again, the reason why we can't use 3 collinear points is because we need to triangulate the plane. Right? The plane is 2-dimensional. Right? It's got 2 dimensions. Right? You can have this way and this way, or to better draw it, let's see, you can have this way or you can have this way, right? 2 dimensions. A line is 1-dimensional, right? It's only going left and right. So we wouldn't know what our second dimension to the plane was if we only used points A, V, and H. We need to create a triangle to triangulate, right? If you have a triangle, if you imagine a triangle, okay, no matter how you rotate it around, it's going to be 2-dimensional. Can you imagine that triangle going on forever, though, to create a plane, right? You have to have 3 points to make that 2-dimensional shape. Otherwise, a line is just going to give you 1 dimension. We don't know what the second dimension is for the plane. So that's why you need 3 non-collinear points to define the plane. Okay, number 8, name the intersection of plane N and plane M. Okay, so plane N is this one. Plane M is then this one. Okay. Imagine that going behind. Okay. Well, the intersection of 2 planes is always going to be a line. And as we look here, right, we see the 2 planes intersect at CD. Okay. So it's going to be line CD. Okay. If you notice, go back to number 7. If you go back a little ways, well, let's scroll up. Okay. The intersection of a line and a plane, well, the intersection of 2 lines, okay, if we go up back to F, right, is a point. So they intersect at a point. The intersection of a plane and a line can either be a point or a line. So the intersection of line AH with plane S is going to be line AH because the whole line is in the plane. Since the whole line's in the plane, that's where the intersection is the line itself. Or you can have it intersect at a point. For example, line XV is going to intersect plane S at point V. Okay, but if 2 planes intersect, they're going to intersect at a line. So 2 lines intersect at a point. A line and a plane will almost always intersect at a point unless the line is entirely contained in the plane, and then they will intersect at that line itself. And then 2 planes will always intersect at a line. Number 9. Use the diagram to find AC. So again, this is segment addition. They're giving us the drawing. So we know the first piece plus the second piece is going to give us the whole thing. So AB plus BC is going to equal AC. Okay. This piece plus this piece gives us the whole thing. AB plus BC gives us AC. AB, they're telling us, is 4. BC, they're telling us, is 10. So AC is going to be 14. right? 4 and 10, right? If you have 4 inches of string, you attach it to 10 inches of string, you now have 14 inches of string. Okay. Pretty straightforward, I think, but I don't know. What do I know? I don't know. Anything, I guess. Okay. So, use the diagram to find JT, show your work. Did we answer the question in the last one? Was it just find AC? Yeah, it was just find AC. Show your work. We showed our work. We get full credit. CJ, let's label our diagram. CJ, 5x plus 7. CT, 34. JT, 4x plus 9. See, I'm looking at this problem, and it's like, how did we not get this right away? How did ever, like, I don't know. I don't know how to explain this, because just, you add the first piece plus the second piece gives you the whole thing, right? Maybe we've done a lot more problems. Maybe if you didn't see it the first time, you'll see it this time. But I don't know how else to explain it, right? If you had a string that was this long and a string that was this long, and you tied them together, your string would now be this long. If you went this far down one road, this far down another road, you went this far total. So CJ plus JT is going to be CT, the whole thing. Okay. CJ is 5x plus 7. JT is 4x plus 9. CT is 34. I do remember you guys wrote 5x plus 7 plus 34 equals 4x plus 9. Because you didn't put it in the diagram. You didn't even look what you're doing. You just rushed through as fast as you could. I do remember that. Okay, this is a plus. Okay, combine like terms. 5x and 4x gives us 9x. 7 and 9 gives us 16. Subtract 16 from both sides. 9x is going to be 18. Divide by 9. X is going to be 2. I do remember a lot of you put that answer and quit, stopped, because you didn't read the question. We're looking for JT. Well, how do we find JT? We know JT is 4x plus 9. We know that x is 2, so we can substitute it in. So JT is going to be 4 times 2 plus 9. So JT is going to equal 8 plus 9, which is going to be 17. So JT is 17. The whole thing's 34. This piece also better be 17. So let's check just to make sure we have our answer right. So 5 times 2 plus 7. 5 times 2 is 10. Plus 7 is 17. 17 plus 17 is 34. If we have a string that's 17 inches long, we have another string that's 17 inches long, we tie them together, our string is now 34 inches long. I guess we did do the best on Unit 1. Unit 2 is when we started to lose people. Okay, the bonus, so draw a diagram that meets the following conditions. Plane pi contains the line AB and point L. Right, contains means within. So if it contains something that's within the plane. So point L is in plane pi, line AB is in plane pi. Second condition, plane T. So we know we have a second plane now. We have plane pi and plane T. Plane T contains lines EF and point S. Okay, so line EF and point S are in plane T. Lines AB and EF intersect in point H. Okay, and then the intersection of plane pi and plane T is LU. So I'm going to start down here. I know I have two planes. I know they intersect at line LU. So I'm going to do my best to draw two planes, knowing full well I will probably have to redraw this. Let me just get this through here. How did we do? That looks all right. So this is plane pi. This is plane T. They intersect at line LU. So this is going to be L. So this is going to be L, and this is going to be point U. Right in the corners here. So we see our planes intersect, plane pi, plane T intersect at line LU. So we're good here. We know we need lines AB and EF. So AB needs to be in plane pi. Line EF needs to be in plane T. Okay, and those two lines need to intersect at point H. So they have to intersect at point H. So I know H is going to have to be in both planes pi and T. So H is going to have to be somewhere on this line. Otherwise, those two lines wouldn't be able to intersect. They have to intersect, right? Because line AB is entirely contained within pi, and line EF is entirely contained in plane T. Okay, so if they're going to meet where the two planes intersect, which is line LU. So it's point H has to be somewhere on line LU. So I don't know. We can have A. What is it? AB. Okay, is this line right here? Okay, goes through point H. And then plane T is line EF. So if we put point E, we draw point F. So here we have lines AB and EF intersect at point H, so we're good. Plane T contains the line EF, yes, and point S. We don't have a point S. We can put that anywhere. I'm just going to put it right here, anywhere in plane T. Then plane pi contains line AB and point L. Again, we can put point L anywhere we want. I'm just going to put it right there. Okay, so we're good here. Let me just double check. Right, so pi contains AB and point L. Plane T contains EF and point S. AB and EF intersect at H, and then the intersection of plane pi and plane T is line LU. So we have everything we need. So that's quiz one. Again, I think you guys, especially quiz one, if you didn't do well on it, if you retook it now, would do significantly better. This last problem is a little tricky, drawing the two planes that intersect. But maybe we should have put this bullet point at the top, because I think if you can do this bullet point first, the rest will be able to fill in. But if you try to do all this and then do the last one at the end, it's going to be a mess. So maybe this bullet point should have been at the top. But you guys got partial credit for doing the other ones. And some of you, I remember some of you did get the whole thing. So that's fine. All right, so that's quiz one. Again, I encourage you to retake it if you want to. Well, I would encourage you to want to retake it. if it would improve your grade in any significant way.